Hello everyone, welcome to Visual Application Programming module. I'm Hasara Maitri. Last week we discussed how we could use repetitive statements, and today we will be looking at the jump statements in C#. So let's get started. Let's look into the first kind of jump statement, the break statement. As the name indicates, the break statement is used to terminate the current loop iteration or terminate switch statements. So we will see how we can use break statement in all of these cases in subsequent slides. So break statement could be used in any loop condition, for loop, while loop, do while loop or switch cases. Now let's look into the flow chart of the break statement. Here you can see that this is the conditional of the loop body, and based on the condition we determine whether we enter into the loop or not. So if it is true, we enter into the conditional code, otherwise we go into the program termination. Also, if there is a break statement, there is another way that we could reach the program termination. That's where a break statement. So break statement can be used to terminate the execution of the whole loop body. So now you understand that given a break statement, we can terminate the for loop condition either by making the condition false or put in a break statement. Now let's look into the second jump statement, the continue statement. And this is quite different from the break statement. As you remember, the break statement terminates the whole loop. But in a continue statement, whenever the condition for the continue statement is true, it skips the execution of only the current iteration. Next, it will pass the program control to the next iteration and it will continue. So in the next slides, we will see how these two statements, break statement and continue statements, can be used in given various scenarios. Now let's look into the control flow of the continue statement. Here you can see the flow chart for the continue statement, and this is the test expression of the loop, and when the test expression of the loop is true, we enter into the loop body. Suppose we have a continue statement in the loop body, and when the condition for the continue statement is true, you can see that the remaining body of the loop is skipped. That means whenever we have a continue statement and its condition becomes true, we terminate the execution for the current loop iteration and we pass the program control to the next iteration. And if the condition for the continue statement is false, then we will execute the remaining body of the loop and go to the next iteration. So now you understand the difference between continue statement and break statement. If this is a break statement, then when the condition for the break statement is true, we will terminate the whole loop. But in a continue statement, when the condition becomes true, we only terminate the execution for the current loop. So that is the difference between break statement and continue statement. Now let's look into an example of the continue statement. Here you can see that we have initialized three lists: even number list, odd number list and prime number list. Based on whether that number is even or odd or prime, we will put the number into one of these three lists accordingly. We have initialized iterative variable for the for loop I to 1, and we are iterating from 1 to 200. So ideally, this for loop body should be executed for 200 iterations. Now let's look into the for loop body to understand what happens. First, it checks whether I is greater than 100. That means whenever I reaches 100 or some value greater than 100, this if condition becomes true and this break statement will be executed so that the whole loop will come into its termination. This is because we are interested in numbers which are less than 100. So whenever I reaches 100, there is no point of checking the conditions. Therefore, even though we have initialized I to go from 1 to 200, the actual execution happens only for 1 to 99. Now, what happens in this is, we take the modular division of iterative variable I by 2. Whenever we take the modular division, what it does is, it takes the remainder of that particular division. So we divide I by 2 and we take the remainder of this division, and we check whether that remainder is equal to 0. When a number is divided by 2, the remainder becomes 0 only for even numbers. So if this condition is true, then we can say that that is a even number. So we add that I to the even number list, and then we execute this continue statement. What happens is, the execution for the current iteration will be terminated and the program control will be passed to the immediate next iteration. So why we have put a continue statement here is, since a number could be either even or odd, and we have already determined that the number is even and we have put it to the even number list, there is no point of checking all these conditions. So that's why we put a continue statement here. Now you understand that why we put a break statement here and why we put a continue statement here. So if this modular division, and if the remainder of this division is not equal to 0, then we can safely say that it is an odd number. So we will add that number to the odd number list. And you know that the only prime number that is even is 2. So all the other prime numbers are odd. So we need to check the prime condition only for the odd numbers. So after that, we check whether that particular odd number is a prime number as well. If so, we will add that to the prime number list also. So that's the idea of this whole code, and you can see that we use the break statement to terminate the whole execution, because we were interested for the values I equals 1 to 99, and we put a continue statement here because a number could be only even or odd, and whenever we determine a particular value is even, there is no point of checking all these else conditions. So that's the idea of this example, and I hope you got it clear. Now let's look into another example. Here you can see that we want to print odd numbers from 1 to 20, and if the number is equal to 5, we need to break number printing further. So which means that whenever this number reaches this particular value 5, we will stop the execution of this printing function. So here we need to use a break statement, because at this value 5 we will come into a termination. Since we want to print the odd numbers from 1 to 20, you can say that we have entered the number as 20 and we click this submit button. Whenever we click this submit button, the statements inside this button submit click method will be executed. So this method is written for the submit event. What happens is, we will first clear any items in the list box, and we will assign the whatever value input here to this integer I. Before that, we need to cast the value into int32, because we initialize this I variable as an integer. So we cast the value 20 to an integer and we assign it to the variable I. So since we are printing from odd numbers from 1 to 20, we will be iterating from 1 to 20. So I is equal to 20. Iterative variable j will be iterated from 1 to 20. First, we check whether the modular division of j by 2 is not equal to 0. That means we check whether j is an odd number. If so, we go inside the next if condition and checks whether j is equal to 5. Since we want to print odd numbers from 1 to 20 that are not equal to 5, we are checking this condition. And whenever j is equal to 5, we will execute this break statement, which will cause the whole loop termination. So ideally, we should only print 1 and 3, since these are the only two numbers which are odd and less than 5. And if the j is not equal to 5, then we skip this if body and we go and add that value to the list box and it will be printed. Now let's look into a few iterations. Now we start from j equals to 1. So 1 is an odd number, so we go inside. 1 is not equal to 5, so we skip this also and we add the list box item to the list box, so 1 is printed here. Now we increment j by 1 and j is now 2, and we take the modular division and it is an even number, so all these things are skipped. So and we go to the next iteration. Now j is 3 and 3 is an odd number, so we go inside the next if condition and we check whether 3 is equal to 5. If condition is false, so we skip the body of the if condition and we add the 3 to the list box, so 3 is also printed here. Next 3 is incremented. Now j is 4, j is an even number, so all these are skipped and we go to the next iteration. Now j is equal to 5 and 5 is an odd number, so we go inside the next if condition and 5 is equal to 5. So if condition is true, that means the break statement will be executed. So we will come into the whole loop termination and program control will be passed to the immediate next statement after the for loop body. So now you can see that only 1 and 3 is printed here. There is another thing I wanted to highlight here. We will be discussing these things in more detail in the later slides. You can see that we have enclosed all these logic inside a try catch block. So why we have put it here is that since we are taking an input from user and we are expecting user to put a numerical value, because you can see that we are casting it to an integer. But it might be the case that user may put any string or a special character. In that case, this typecasting to an integer might throw an error. So in order to handle such errors, we use this try catch block. So that's a additional point that I wanted to highlight here. So I hope now you understand the logic and why we have put the break statement in this example. Now let's look into another example. Again, we want to print odd numbers from 1 to 20, but here we will be printing all the odd numbers from 1 to 20 except for value 5. The difference between the last example and this example is, in the previous example, we stopped the whole termination of printing whenever the number reaches 5. But here we will not stop termination, but will stop it only for the value 5. So we will use a continue statement here. Whenever the value reaches 5, we will put a continue statement to stop the termination for that particular current iteration, and we will continue the execution from the next iteration onwards. So again, we will use this text box to put the number. Since we are printing odd numbers from 1 to 20, we enter the number 20 here, and we have a submit button. And this is the submit click method written for this button, and Again, all the methods are similar. I is initialized by value 20, and we are iterating the iterative variable j is initialized to 1, and j will be iterating from 1 to 20. Now let's look into the code. So starting from j equals to 1, 1 is an odd number, so this if condition is true, and we go into this if condition and we check whether 1 is equal to 5. So if condition is false, so we skip this if body, and we skip the if body, we add the list box item to the list box. So 1 is printed, and we will increment j by 1. Now j is 2, so j is an even number, so all these if body is skipped, and we increment j by 1. Now j is 3, and j is an odd number, so we go inside the if condition and we check whether 3 is equal to 5. So that condition is false, so we skip the body of that if condition and we add 3 to the list box. 3 is printed, and now we increment j by 1, so now j is 4. J is not an odd number, so all these statements are skipped, and we go into the next iteration. Now j is equal to 5, so 5 is an odd number. We go inside the if condition, we check whether 5 is equal to 5. Now the if condition is true, that means we will execute the continue statement. So the remaining loop body for the current iteration will be skipped, and the program control will be passed to the next iteration. So that means we won't be adding 5 to the list box. So here you can see that 5 is not printed. Now j is equal to 6. So 6 is not an even number, so we skip all this and we go into the next iteration. Now j is 7, and 7 is an odd number, and 7 is not equal to 5, so we add the list box 7 to the list box, so 7 is printed. Likewise it goes on. So now you can see that since we have put a continue statement, whenever j reaches the value 5, the particular print function is not executed for the value 5, and for all the other values it is executed, so that all the odd values from 1 to 19 except for value 5 is printed in the list box. So now you can understand the difference between the previous example and this example. So in the continue statement, based on the loop we use, there are slight differences. For example, in the for loop, the continue statement causes us to go into the incremental portions and the conditional test. But in a while loop or a do-while loop, there is no incremental portion inside the while loop or do-while loop initialization. So the continue statement passes the control to the conditional test. We will look into an example where we use continue statement in a while loop and do-while loop and understand these things better. Alright, let's look into an example where we use break statement in a while loop. Here we want to print the first 10 square numbers. But according to the example, we want to break the print in square numbers when it reaches the value 9. So ideally it should print only 1 and 4, since 1 and 4 are the only square numbers which are less than the square number value 9. Since we want to, so let's look into this button display click. So this is the display button that we have here. Whenever we click this display button, the logic inside this button display click will be executed. So first we clear the list box, and this is the list box, and we initialize the variable I to 10. Since we want to print the first 10 square numbers, we have to run this while loop for 10 iterations, and we initialize j to 1. So this while condition is written such that the logic inside this while loop will be executed as long as j is less than or equal to I. So that means this while loop will be iterated for 10 iterations. J is 1. We get the first square number by multiplying 1 by 1. So j is 1, the square number is 1, and we check whether 1 is equal to 9. So it is not. So we skip this if body and we add the square value to the list box. So 1 is printed here and we increment j by 1. Now j is 2. So still 2 is less than or equal to 10. While condition is satisfied, we get the second square number by multiplying 2 by 2, 4. And 4 is not equal to 9. So we skip the break statement. We add the 4 value to the list box. So 4 is printed. Now we increment j by 1. J is 3 now. Still 3 is less than or equal to 10. So while condition is satisfied, we get the third square number by multiplying 3 by 3. Now the square value is 9, and yes, 9 is equal to 9. So if condition is satisfied, so we go into the body of the if condition. So the break statement will be executed, which means that the whole while loop will be terminated and program control will be passed to the immediate next statement after the while loop. So now that's how we can use break statement inside a while loop body. You can see that in this we only have a statement to check the condition. The increment of the iterative variable is done here by ourselves. So that's the difference between the for loop and the while loop. And now you know we can use this break statement for all these loop in order to stop the execution of the iterations. Alright, now let's look into an example where we can use the break statement in a do while loop. In previous example we looked at the while loop, now we are looking at the do while loop. In this we want to display the numbers from 25 to 1. So here you can see that in the printing function, the value after the value 16, the printing is terminated. That means at the value 15, we have to put a break statement so that the execution will be terminated. So now you understand that for this to achieve, we need to use a break statement. So let's look into the code here. So we have a display button just like in the previous example, to which we have written this button display click method. Again, we have initialized I value to 1 and j to 25. Since we want to display the numbers from 25 to 1, we have initialized j to 25 and I to 1, and we will be iterating this do while loop until j is greater than or equal to I. So this will be executed till 25 to 1. In a do while loop, the difference is that irrespective of the condition, the do block is executed for once. So suppose this condition is not satisfied, that means j is already 0, still the do block is executed. So we are guaranteed that no matter the condition is, do block will be executed for one iteration. Now let's go inside the do block. So we check whether j is equal to 15. No, since j is 25, we skip the if condition and we add the 25 to the item box. So 25 is printed. And we decrement j by 1, so j is 24 now. And we check whether 25 is greater than or equal to 1. And yes, it is true, so we execute the do block again. And now we check whether 24 is equal to 15 or it is not. So we add the list box 24 to the list box, so 24 is printed. and we decrement j by 1. Now j is 23. Again this while condition is satisfied, we execute the do block again. So this will be executed likewise. Now assume the case where j is equal to 16 and we check whether the condition is true. Yes, 16 is greater than or equal to 1, so we execute the do block. And no, j is not equal to 15, so we skip all this if condition, if body, and we add the 16 to the list box. So 16 is printed now, printed here, and we decrement j by 1. So now j is 15. Still 15 is greater than or equal to 1, so we run the do block and we check whether the 15 is equal to 15, and yes, condition is true. That means we will increment the j by 1. So now again j is 16 because earlier j was 15 and we add 1, so j is 16 and we break the condition. That means whole do while loop will be terminated and program control will be passed to the immediate next statement after the do while. So that's how you can see that the printing function is terminated at the value of 50. And this is an example where we can use the break statement inside the do while block. So I hope now you have an understanding where we can use the break statement in for loop, while loop and do while loop. Now let's look into another scenario where we can use the break statement in a switch case. So here again we take a input from the user and we cast it to int, and based on that we determine to which case we belongs to. So if the integer that is input by the user is 1, we go into this case. In the message box we show that number 1 is core, and after that we execute the break statement so that we don't have to go through each case individually, because at one point it could be that only one of these cases could be true. So since we have already got into the case where we belong, there is no point of checking all the other cases. So we execute the break statement and we stop the termination of all switch case. So this is how you can use the break statement with the switch case. Now let's look into another type of jump statement used in C#, the goto statement. The goto statement is used to transfer control to a label statement in a program. And this label statement should be a valid identifier so that the program knows where to transfer the control. So that the label statement should be existed in the scope of the goto statement. Otherwise the goto statement would know where the label statement is, so it will throw an error saying that it is not identified. Also, more than one goto statement can transfer control to the same label. So we can have many goto statements pointing to the same label. Also, the goto statement can be used to get out from an inner loop to an outer nested loop. So we will be iterating inside an inner loop and we can use a goto statement to get out from this inner loop and pass the control back to the outer loop. Now let's look into the flowchart of the goto statement. Here you can see that we are executing statement 1, 2, 3, and at statement 3 we can have a goto statement saying go to the statement 1 so that the program control will be passed back to the statement 1, and this will, you can see that this will be a continuous loop. Now let's look into an example where this goto statement is used so that you will be able to understand what I said earlier. This is the class goto example, and this is the main method at which the program execution starts. We have initialized a variable called number to 20, and based on the value of that number, we have put a switch case here. So if the value of that number is 5, this will be printed, and if it is 10, this will be printed. If it is 20, this will be printed, and this is the default case. So now number is 20, so this case is false. We check whether the case 10 is true, and again it is false, and we go to the next case, and yes, it is true. So what happens is it executes this line, the console write line case 20. So in the output, this case 20 will be printed, and we have a goto statement here. It says that go to case 5. So the control flow will be passed to this case 5 from the goto statement, and the console write line case 5 will be printed as well. So here you can see that case 5 is also printed, and then it will execute the break statement so that the execution of whole switch case will be terminated, and program control will be passed to the next immediate statement after the switch case. So now you can see that then this case 5 is that label that the goto statement has identified, and this case 5 is within the scope of this goto statement, so that goto statement knows where this case 5 is pointed to. So also you can have many goto statements pointing to the same variable case 5. I mean, even in case 10 you can put go to case 5. So now you can understand that how we can use the goto statement to pass the control to a particular point that we want in a program. Let's look into another jump statement, return statement. Return statement is used to terminate any execution flow in any method, and it returns control to the calling method. For example, say we are calling a particular method from the main function. So the calling method would be the main function, and we will be calling to a method, say let's say method A. So after executing all the statements in the method A, we will put a return statement at the end of the method so that it will pass the control back to the main methods. So that's how we can use a return statement. Also, in a method, it is optional to return a value. Sometimes we might be returning a particular result from a method, or we won't be returning anything. So if we are not returning anything, we need to initialize method with return type void. Or if it is returning a particular value, then we have to initialize the method with its data type. We will look into an example and understand these things. Now let's look into an example where we can use the return statement. Here we have defined the class called return example, and this is the main method from which the program execution starts. And additionally, we have another method called addition, and it has a parameter variable type int, and you can see that the addition method is initialized with the data type int. That's mean we will be returning a data type of integer type. So let's see what this addition method does. So it takes the parameter a and it add a with a and assign the value to the add variable, and it returns this add variable. So you can see that the data type of this add variable matches with the data type that is initialized for the addition method. Now let's look at the main method. So from this point onwards, the program control starts. We assign the value 2 to the variable number, and we call this addition function by passing the number as the parameter. So the program control is passed to this addition method, and int a is assigned with value 2 because number is initialized with value 2, and we add 2 with 2, 4, so it returns the value 4. Again, from this return statement, the control is passed back to the main program and the assignment happens, so the value of the result will be now 4. So when we print this line to the console, it will print as the addition is 4 because the value of the result is 4. So now you can understand how we use return statements to return values from the methods. Also, there could be cases that we won't be returning any value from a particular method. In such cases, instead of the data type, we put the keyword void here. So you will be seeing many such cases where you want to do a particular function, so you will need to write that code inside a separate method and call that function from the main method, and using the return statement you will want to get the result back to the main program. Okay, let's look into the last jump statement, the throw statement. We use throw statement to throw exception errors to the program control flow. So in order to create these exception classes, we need to use new object with the valid exception classes designed for that particular programming language. And in order to use the throw statement, we have to combine it with the try catch or try findy blocks. These blocks catches the particular exception that is thrown from the program and outputs a particular message to the user. So we will look into an example and see how the program flow and execution happens. Now let's look at this example. Here you can see that we have the main method where the program flow control starts, and we have another method called display subject, and you can see its return type is void, which means that this method won't be returning any value, and it takes a one input parameter sub1. Let's see what this method does. And here, and first of all, you can see that a string sub is initialized to null. Now let's see what this method does. It checks whether the parameter that is passed to method, which is sub1, is null. If it is null, then it creates a new exception class, new object from the exception class null reference exception. So in C# we have this exception class called null reference exception, from which we can create new objects. So using this new keyword, we create a new null reference exception object and we throw it to the program flow. And also we can pass a message here. So here we have put it as exception message. Now let's see how the program control happens. It starts from the main method, and you can see that there is a try catch block. It calls this static method display subject and pass the parameter as subs, which is initialized to null. And you know that and the program control goes to this method call, and the parameter that is passed to sub1 is sub, which is a null, and so if condition is satisfied, it throws a new exception object, and this try catch catches that exception, and this exp is initialized with that thrown object. What happens is it will print into the console the message of that exception. So message would be this statement we have put within this double quotes. So output would be exception message. Now you can understand how we can use throw statement along with try catch to handle various exceptions or errors that we might get during the program execution. For example, I mentioned this earlier in the slides as well. Assume we have a method where we take user inputs and we want to we want, let's say we take two inputs from user to divide them. Say those I and B, we want to divide A by B. So we expect user to input numerical values, but it might be the case that user may put any random value like strings, special characters likewise. So if such inputs are given, then that division might throw an error. So in such cases we have to handle those using this throw statement along with the try catch block. So that is a real world use case where we could use this. So I hope that you have understood the main concepts and the jump statement, main concepts of the jump statements. So if you have any further questions that you want to clarify, please put them in the comment below so that I will be able to answer. And thank you very much for the participation.